So this is nitroalkane topic. Nitroalkane, they can be classified broadly into aromatic nitroalkane and aliphatic nitroalkane. Aliphatic nitroalkane are also called nitroparaffins because paraffin is a word for alkanes, right? So nitroalkane are also called nitroparaffins. And nitroalkanes are generally of three types: for primary, first degree, 1 degree, secondary, 2 degree, and tertiary, 3 degree. So primary nitroalkane is the nitroalkane where NO2 functional group is attached to the primary carbon, right? This is the primary carbon of this compound. This is the primary carbon, and it is attached with the primary carbon. It is 1 degree nitroalkane. And in 2 degree nitroalkane, this carbon is a secondary carbon because it is attached to two alkyl groups, right? This is an alkyl group and this is the other alkyl group. So carbon, which is secondary in nature, if nitro group is attached to this secondary carbon, then that is said to be 2 degree nitroalkane. And similarly 3 degree nitroalkane, the carbon attached with three alkyl groups, right? So it is tertiary carbon, and nitroalkane attached to a tertiary carbon is known as tertiary nitroalkane or 3 degree nitroalkane. So this is a nitro group R and double bond O and a coordinate bond O with a coordinate bond between nitrogen and oxygen. This is a nitroalkane and it is isomeric with nitrite group, right? So this is a nitrite group. This is a nitrite group, right? R O double R and double bond, sorry, R and O2 is called nitroalkane, whereas R O and O is called nitrite. So this is a nitro, so this is a nitro group, whereas this is a nitrite group. Again, so these are the functional isomers of each other, right? These are the isomers, but the functional group is different. Here is the nitro group and here is the nitrite group as the functional group. So these are the functional isomers of each other. Now let's move on to preparation of nitro compounds. How can we prepare nitro compounds? The first and foremost way of preparing nitro compounds or nitroalkanes is by using alkyl halides, right? Alkyl halides, when treated with alcoholic sodium nitrite, we get nitroalkane. Now the thing to be considered here is, along with nitroalkane, right, it's a high yield of nitroalkane, 70 to 80% nitroalkane is formed, but along with this a small amount of alkyl nitrite might also be formed, RONO. So along with nitroalkane is the major product, but along with this small quantity of alkyl nitrite can also be formed, but we only want to get nitroalkane. So how can we separate this nitroalkane and alkyl nitrite? The way to separate these two is fractional distillation, right? Fractional distillation is used to separate nitroalkane and alkyl nitrite. Again, the other important thing to consider here is we're here using alcoholic silver nitrite and we cannot use aqueous silver nitrite, right? Aqueous silver nitrite can never be used because that will form alcohol in place of nitroalkane, right? So when we use aqueous form of sodium nitrite, it will give alcohol, but we are preparing nitroalkane, so this method is not used. Again, in place of silver nitrite we cannot use sodium nitrite or potassium nitrite, so these metal nitrites cannot be used because again that will form alkyl nitrite in place of nitroalkane, right? So if we are wanting to prepare alkyl nitrite, we can use if we are wanting to prepare alkyl nitrite, we can use potassium nitrite, but here we are preparing nitroalkane, so only alcoholic form of silver nitrite can be used. And the other method to form nitroalkane is from alpha halogenated acid. So this is a carboxylic acid, right? So CS3COOH is a carboxylic acid, and the alpha carbon, right, the alpha hydrogen is substituted by the chlorine atom, so this is alpha halogenated acid. alpha halogenated acid when treated with sodium nitrite. Here sodium nitrite is used, right? Sodium nitrite, then nitroalkane is formed along with carbon dioxide. So the point to be considered here is decarboxylation also occurs along with nitration, right? Along with the formation of nitroalkane, we're also getting carbon dioxide. That means one of the carbon atom, there are two carbon atoms in the substrate, right? But in the product we get only one carbon atom, so here occurs decarboxylation. This is an important aspect. The other is from alkanes. From alkanes, by treating with fuming nitric acid. Fuming nitric acid, HNO3, at the temperature of 450 Kelvin. When methane is treated with fuming nitric acid, nitromethane is formed, and this is basically free radical mechanism, right? It follows free radical mechanism because the temperature is very high. It is fuming nitric acid, and when we use propane, right, higher alkanes are used, then we get the mixture of nitroalkanes. We get 1 degree nitropropane, we may get 2 degree nitroalkane, we also get nitroethane and nitromethane as well. So a mixture of nitroalkanes are formed when we use higher alkanes, right? When we nitrate, like when nitration is done with higher alkanes, we get a mixture of nitroalkanes. And also the reactivity order, of alkanes is tertiary. It has highest reactivity, it is followed by secondary, and finally primary. Now what happens here is, the tertiary alkane is more reactive, right? Because it has like 3 alkyl groups, and these alkyl groups are, we know, they can donate electron, right? So when they donate electron, this carbon becomes highly electronegative, and for the attachment of this NO2 plus nitronium ion, in tertiary compounds, it is much easier in comparison to secondary and the primary alkanes. Now again, let's move on to the nitration of arenes. Now formally when we studied nitration of alkanes, here when we studied nitration of alkane, it followed free radical mechanism, right? Carbon free radicals were formed in this reaction, no carbocation, no carboanion. But when we nitrate arenes, aromatic compounds like benzene, right? When benzene is subjected to nitration, it follows electrophilic substitution mechanism, because here we get an electrophile in the reaction mechanism, which is actually nitronium ion, right? So NO2 plus nitronium ion acts an electrophile, and we obtain this nitronium ion from a mixture of concentrated nitric acid and concentrated sulfuric acid, which is also known as nitrating mixture. And here HNO3, nitric acid, acts as a base, and this acts as an acid. So when benzene is nitrated, it forms nitrobenzene. A very simple way. And this is also the laboratory preparation of nitrobenzene, right? So from diazonium salt, here the structure, here a compound, we're saying this is a diazonium salt because we have this 2 nitrogen. Diazo means 2 nitrogen, and salt, here's a chlorine atom. This is a diazonium salt, and when this diazonium salt is treated with nitrous acid is HNO2, which is formed by mixing sodium nitrite and hydrochloric acid. When these two are mixed, nitrous acid is formed. And when benzene diazonium salt is treated with nitrous acid, we get nitrobenzene along with emission of nitrogen gas. So nitrogen gas is also emitted, and nitrobenzene is also formed. Here is a small note I have written: nitration of alkenes proceed by free radical mechanism, but nitration of arenes proceed by electrophilic substitution. This is a very important point that we have to consider. Now let's move on to some of the physical properties of nitric compounds. Aliphatic nitric compounds are colorless liquids like